So let's look at some more basic functions. So we just did 1 over x, but what if I get rid of if I stop talking about reciprocals and just look at x squared. All right, so there's a family of similar looking things here too. What am I doing? I just went from x squared to x to the fourth, and now I can go to x to the sixth and x to the eighth. You can see that it looks kind of the same every time, right? And so um, why does it look like this? Well, there are, several correct lines of reasoning, I guess. How do we say objectively what looking like this means? Well, for one thing, it's symmetric about the y-axis, right? You can see that it looks the same. It's a reflected mirror image across the y-axis. That's because this function is x raised to an even power, and even powers do the same thing to negatives as they do to positives, right? So anything it does to over here on the positive side, it's going to do exactly the same thing on the negative side, because even powers can't tell the difference between odd and negative and positive numbers. And why does it go up really steeply? That's just the nature of raising things to a power. So power functions grow really fast. Alright, so let me write all that down, what I just said. Go down to the bottom of this thing, get a new page. Alright, so this is something that we need to know. We need to know, and I lost my thing again. We need to know that, that's not such a great picture. We need to know that x to the n for any even n looks like this. Okay, alright, and we just, we graphed a bunch of functions and just proved why it was true. So what else? So we should look and see what happens in the odd case. So what do you think the difference is going to be? Well, x cubed grows really fast, just like x squared does, so this part looks the same. But remember, in the previous video we said when we cube a negative like -5, then all but one of the negative signs cancel out. So we pair them up and they cancel each other, but when you raise something to an odd power, there's always one left over, and that makes the result negative. So it's going to be just like this picture up here, except instead of these numbers being sent up to something positive, they're going to get sent down to something negative. And so it's kind of just like twisting one of those horns around. You can imagine grabbing this part with your hand and just bending it down like the lever of a slot machine. You get a picture like this. So this is what x to the n for n odd looks like. Alright, and let's take a picture, or take a look at some of those. So I'll change this to, let's look at 3, and you can see that the kind of thing that I was talking about is happening. Also notice that just x is an example, right? X is a really silly example. It looks kind of like x cubed in the way that I've been talking about. Now let's change this to x to the 5th, and change it to x to the 7th, and x to the 9th, and you can see that it's the same basic shape, it's just getting steeper and steeper and steeper. Okay, so that is how power functions work. Alright, so is there anything left to say? So there are, why is this thing always running out of paper? It's so frustrating. So there are other things to look at, actually. So what about a function like f of x equals x to the 1/2? So what are we doing? We're looking at functions that are like x to the something. So we looked at even numbers, and we looked at odd numbers. And since 1 over x is x to the -1, we even looked at negative numbers, right? We looked at x cubed. What does that look like? You should remember it looks like this. And so this is x to the -3. That's just what the notation means. It's just The notation, the rule for the notation is when I say x to the negative 3, what I mean is this. That's just the definition of the way the notation works. So we've looked at power functions where this exponent is any whole number. We've checked the odd ones and we've checked the positive ones and the evens and the odds. The only thing left is, what did these functions look like when this thing is a fraction? So, I don't know, let's have this graphing machine tell us. So it looks like that. Okay. Alright. And there's kind of an explanation of why it looks that way, if you understand why am I not going anywhere? Sometimes it freezes up. Oh, and it's frozen now. Let me see if I can turn it off. Oh, sorry, I'm gonna have to quit.